Hello there. In this video we're going to solve for the inverse of a rational function. So I'm going to do this with the version where we swap x and y. This f of x, just think of that as y. So let's swap those, rewriting the equation. So there's several ways of going about doing these problems. Ultimately we want to get y by itself, but you'll notice that we got y in both the numerator and denominator. So let's get rid of the fractions by multiplying both sides by that y plus 3. Alright, so that gets rid of all the fractions. Next step, let's distribute. Alright, so not losing eyes on our ultimate goal, we had swapped them, so we want to rewrite this and get y by itself. I got y's both here and here, so I'm going to gather like terms. And things that aren't y's, I'm going to put on the other side. I'll swap those. Now we could have done this to the other side. Like maybe I even want to do that. I don't like all those negative ones. Well, we'll worry about that in a moment. On the left hand here, these are not like terms, x, y, and 2y. They both have y's, but I can't gather them. But the magic trick here is that we can factor. That's what this one is all about. And at that point we can divide by what we had factored out. And for the final step, we can write this in our inverse notation, that the inverse of f of x is equal to this whole thing that we got here. And if we had wanted to, we could have actually written this where we make the top positive. There are advantages in doing that by making the bottom negative, and effectively swaps it. So either version of this would be right. Now a couple interesting things here. So actually let's kind of refer to this as like blue. So there's going to be the symmetry in them, and you can kind of scan through and check to see how you've done on these problems. In the original one, there's a vertical asymptote. That's where we have that domain error. So that one has a vertical asymptote at x equals -3. And in the original, we got linear over linear. So that's case 2, and the coefficients are 2 over 1. So we have a horizontal asymptote at y equals 2. Now in the inverse equation, doesn't really matter which one I use, the vertical asymptote here is when that denominator is 0, and that's going to be at x equals 2. And the horizontal asymptote, again, we got linear over linear, and it doesn't matter which one I look at. So here it's all in front, -3 over 1. Or here it's 3 over, that would be -1, so that's -3. And what you can see is that these are swapping places. The vertical asymptote of one becomes the horizontal asymptote of the other, and vice versa. And there's actually even more than that going on too. So this is good practice from all that stuff we did back in Unit 5. Okay, x-intercept here. That's where the numerator is equal to 0, and that is going to be at 1/2. So I got 1/2, 0 there. The y-intercept, I put in a 0, and that stuff's going to cancel out. I'm left with this, -1 over 3, so that is -1/3. When I look over at my inverse function, I need to make the numerator 0. Lots of negatives there. Let's just do this one. That's equal to 0 by making that x -1/3. So -1/3 there. And the y-intercept, when the x becomes a 0, that stuff is gone. You get 1 over 2. That stuff's gone. You get -1 over -2. That is 1/2. So what you're seeing here is that these are swapping with each other. That x-intercept, the y-intercept in one is becoming like the x-intercept in the other, and vice versa. So there's this is a way to kind of double check to make sure that you did all of this algebra over here correctly. And if your vertical asymptote of one's not becoming the horizontal asymptote of the other, or the x-intercepts aren't swapping, then something probably happened over here. Thanks for watching. Character and Scholarship for Life.